So Monday's lecture focused primarily on the between subjects or independent measures t-test. And this is a good time to kind of remind everyone that these two terms are fairly interchangeable. So a between subjects t-test or an independent subjects t-test is the same thing. It's just two different ways to define the same issue. And that issue being whether or not people are in each group are different from each other. So remember that if we're doing a t-test, it means we have two variables. One of them is our IV, and that is a categorical IV with only two levels. In other words, we are comparing two different groups. If those groups are different, they're called between subjects or independent. In other words, each group is different from the other. We're comparing between subjects in group 1 and subjects in group 2, which are independent, different people. And what we're comparing them on is a continuous variable, the DV. So the main thing I want to make sure that you know for the test before we move on to the next form of t-test is exactly what makes an independent or between subjects t-test. The big question there is, if you walk it down, is do I have two variables? Are one of them categorical with two levels, which I'm deeming an IV? In other words, am I comparing groups? Am I comparing them on a continuous dependent variable, an outcome variable, if you will? And are the people in each of those groups different people? If so, we're at the between subjects or independent subjects t-test. Now, we went through how to actually conduct a t-test and interpret the results from SPSS, and I would strongly suggest that you review those and make sure you know where to look in the SPSS readout for a t-test between subjects. That is probably something you're going to be tested on Friday. But we also went over how to hand calculate that test equation. And again, the equation is right here, and the equation is the first equation shown. And we're basically on the top of the equation, we simply have our two means, mean 1 minus mean 2. On the bottom of the equation, we basically have our standard deviations of group 1 and group 2. We're going to square those. We're going to divide them by the n of the group, so not the total n. So if I had 32 participants and I split them into two groups of 16 and 16, then N1 would be 16 and N2 would be 16. If I had 25 participants, 10 in group 1 and 15 in group 2, then the N of 1 would be that 10 and that N of 2 would be that 15. So it's not your total N, it's the N of that specific group that we're getting that standard deviation from. Other than that, we're just going to plug and chug those numbers in, run the equation, and we're going to get our actual calculated t-test statistic, which we'll then have to use our degrees of freedom. Again, the degrees of freedom of this particular test is n minus 2. Find what is that critical value and determine if we have statistical significance. If we do have statistical significance, we do need to hand calculate, even when using SPSS, the actual effect size of that t-test. And the effect sizes of t-test is Cohen's d, and it's a very similar equation to what we use to actually calculate the t-test itself. The only change here is that instead of the n of the groups, we're dividing the standard deviations of each group by 2. So that's a standardized score. That 2 does not change. So once again, we're going to get the means from group 1 minus the means from group 2. We're going to get the standard deviation from group 1 and square it. We're going to get the standard deviation from group 2 and square it. But then we're going to divide by 2 instead of n. Run that square root, do that division, and get our Cohen's d. And just as a quick reminder, the effect sizes on Cohen's d, 0.2 is small, over 0.8 is large. You can get a Cohen's d well above 1.0 though, so it is not a measure of shared variance like r squared. So today we're going to build on that knowledge set, so we're basically going to look at a specialized t-test, the repeated measures are within subjects t-test. So it is very, very similar as far as its requirements and what we're doing to the t-test we've already covered. Once again, we're going to have two variables. One of those is going to be an independent variable that's categorical, again with no more than two levels and no less than two levels. And we're going to have a dependent variable, which is normally distributed and is continuous. The only difference here is that with the repeated measures or within subjects t-test, and again, these terms are interchangeable, it means the same thing. Repeated measures means that we're repeating the measures. We only have one group of people, but we're exposing them to two levels of our independent variable. In other words, it's the same people. It's the same people in group 1 as in group 2. Within subjects is another way to say that. So instead of comparing two different groups of people, I'm comparing the same group in two different conditions. I'm comparing within those subjects, their exposures to my independent variable. Now, I did talk on Monday, and I'll repeat again, that if you have made an effort outside of random assignment or just pre-existing groups to match your samples. In other words, if you've gone through a process of making sure, for example, gender, ethnicity, and GPA are fairly equally represented in both groups, you would also be using this test, but you would also then have to justify how well of a job you did on matching. And I kind of suggested that generally, if we can avoid it, we don't want to get into that gray zone of matching. We want to use this test when we're using the exact same participants. It's the cleanest use of this test. And if we can't use the exact same participants to expose them to each level of our independent variable, then we should probably use random assignment or pre-existing groups that we haven't actually tried to mess with for the other test. So again, we're going to be trying to add, this is yet another technique to add to our toolbox. And that toolbox is all the statistical techniques that we're learning to recognize when we would use them and how we would use them and how we'd interpret them. So again, what is a dependent group? So within participant match designs, or match samples is what a dependent group is. In other words, we are now actually removing independence from the groups. We're either removing that independence because they're not independent, they're the exact same people, or we're removing that independence because it's no longer unnaturally occurring or randomly assigned groups. We are going in and determining who is in each group. In other words, the determinant is us, the researcher. We're making them dependent on each other because they're dependent on our decisions of which group they went into. Now, because these groups are either equated, because they're the exact same people, the difference between the first mean and the second mean is less likely due to any irrelevant differences. In other words, we're much less likely to see error or noise in this kind of design. A lot of what we're having to adjust in our calculations of these statistical techniques on the bottom of that equation. Remember, the top of the equation is always the effect. The bottom is always an estimate of all the variance and noise. And a lot of times we're having to basically estimate a fair amount of noise. There is different people in each group. So individual differences, personal differences, differences in mood state are all things we have to somewhat account for. If it's the exact same people in very similar conditions with only one single variable change, that independent variable that we're looking at, that categorical variable, then we don't have to estimate a lot of irrelevant or individual differences because we'd assume they're not there. So again, those irrelevant differences among our participants are different than if our groups are independent and are different. So there's a smaller amount of error variance at the bottom of the equation, and therefore we get a larger t. So remember, larger numbers, more likely to find significance. And if the effect size is the same, but the bottom of the equation is now smaller, in other words, a smaller estimate of error, since our equation is effect divided by error, if error is smaller, effect is going to be larger at the end of that division process. So that's how this becomes a more powerful test, because we are not having to estimate as much variance or error outside of our actual effect. So basically, it's often referred to as a direct difference method. In other words, we're simply looking at the difference between the two scores from time 1 to time 2, group 1 to group 2, because it's the same people. And then the only variance we have to worry with about beyond that is the variance within the group itself. So again, we're looking at a situation where we're having to estimate less error. So basically, the theoretical equation here is simply the difference between scores divided by the standard deviation of that difference. This results in a higher t. Degrees of freedom for this test is n minus 1. So if you remember that when we did between subjects t-tests, our actual degrees of freedom was n minus 1, n minus 1, which equaled n minus 2. In other words, it was the n of group 1 minus 1, the n of group 2 minus 1. But an easy way to calculate that is just the total number of participants you had in both groups minus 2. So basically, the degrees of freedom here are the same, except that we only have one group. So instead of n minus 2, it's n minus 1, with n being the number of people in either group because they're the same number of people. So again, if you were using this for matching, you would also want to make sure that your two groups were as equal as possible. So we can also see our degrees of freedom are higher. So if I was running 30 people through a between subjects test, that'd be 30 minus 2. That would be a degrees of freedom 28. And remember, the larger the degrees of freedom, the smaller the number is for us to be able to claim significance. That same 30 people in a dependent studies design or a within subject design, 30 minus 1 is 29. 1 degree of freedom higher, it's going to be a little easier here also to find significance. So let's run through our sample. So let's talk about how we'd actually conduct this, when we'd be conducting it. And I really want you to think about, again, that defining feature of what's the difference between subjects and within subjects. And that is whether or not you have two groups of different people or are the same people being exposed to different levels of an IEV. So in this case, Dr. Z wants to study the effects of type of word, concrete versus abstract, on learning. So 8 students were asked to learn 20 concrete words, and then after a brief span of time, 20 abstract words. Recall for all words is tested. So basically, if you came into the study, you would be asked to learn 20 concrete words. So concrete words would be like car, tree, dog. In other words, they're words for things that have concrete meaning within our world. They're physical objects. And then after a brief time, let's say 5 minutes of delay after you learn the 20 concrete words, you'd be asked to recall as many words as possible. That's our DV, how many words you recalled. Our second condition, maybe 15 or 20 minutes later, the participants are asked to learn 20 abstract words. Abstract words would include love, war, things that are a little harder to actually put to a direct concrete concept and are more abstract terms. So again, they're going to learn 20 abstract words. And again, after a brief delay, they'll be asked to recall as many as possible. So our IV in this condition is whether you learn concrete or abstract words. That's a categorical IV, and there's 2 levels, 20 concrete or 20 abstract. Our DV is how many words you recalled, a continuous variable. And again, we know it's a within subjects or dependent groups design because we have 8 students that were asked to do both. In other words, it's the same 8 students in condition 1 that are in condition 2. So in this case, our data is going to look like this. We're going to have our participants, we're going to have their concrete total and their abstract total. So we're going to basically have a data file with a participant and 2 outcome variables. In other words, what was their score on the outcome DV, the continuous variable? What was their total number of words remembered in the concrete condition? And what was their total number of words remembered in the abstract condition? Now notice there's also columns C1, C2, C3, C4, C5, C6. This is basically how many, did they remember that concrete word or not? So the data file here is going to be a lot bigger, but we already did the homework of basically just getting the total score. How many actual words did they remember? Because that's what we actually want to look at. So we have our participant number, total number of concrete words recalled, and total number of abstract words recalled. And again, we're not going to use the participant number in the actual analysis. What we need to do is compare the continuous variable in the C total condition to the continuous variable in the A total condition. So once again, we're going to go to Analyze, Compare Means, and this time we're going to scroll past that one sample t-test because we have more than one sample. We're going to scroll past independent samples because we don't have different people in these 2 groups, and we're going to settle on paired sample. Notice SPSS calls it paired. They don't call it within, they don't call it dependent, they call it paired samples. Yet another way to say the exact same thing. So now what we're going to have to do is actually create our DV and our IV, because notice we don't really have an IV variable here. What we have is 2 DVs, but we don't want to look at 2 separate DVs. The DV is our outcome. So the first thing we're going to do is we're actually going to select our first measure, which represents the scores from group 1, and we're going to put that in. We're going to click on it and put it down to variable 1. We're then going to check our second group, the abstract condition, click it, and bring it over to variable 2. Once we've done that, we're going to hit the arrow key to bring it over. And what we're going to see is a variable is being created that compares the difference, both mean and standard deviations, of the C total variable versus the A total variable. So basically, we've just told SPSS this is our categorical variable. We're having to define it because the way it actually appears in the data set is that we don't have a separate column for the IV. We have 2 columns for a split DV. So we need to tell SPSS what to do with that. We're going to click OK, and here's what we're going to get. So basically, we're going to get the information of the means and standard deviations of our first group versus our second group. So the C total, they remembered 13.25 words with a standard deviation of 2.96. And again, in the atotal condition, they remembered 10.375 words with a standard deviation of 3.02. So again, we're getting our means and our standard deviations, and also notice that n. That n doesn't mean there are 16 people, it's the same 8 people in both conditions. Notice we're going to get a correlation here with a significance value. Now, we're not going to really talk about this much, but remember that what we're actually doing is a little bit different than a standard t-test. We're not comparing directly the two means. We're actually looking at effectively two continuous variables that we're defining as different based on an IV. And therefore, we are going to get a correlation value. The main reason I point this out is we will need this later when we actually want to figure out the effect size. So here's the actual statistical information. The mean here is the mean difference. So these are our paired differences. Like I said, this is the difference between those two means. And we also see right afterwards is the standard deviation of those two means. We're not as concerned with that. And finally, at the very end of this, we're actually going to get our t-test. So the t is calculated to be 2.392. Degrees of freedom is 7, 8 minus 1. Significance in this case is 0.048. So rounded up 0.05. It is significant right on there. So again, I just want you to kind of take a look at this and recognize where in SPSS we're getting this information, where the means and standard deviations are coming from, and keep in mind where we'd get that correlation and mean difference later, because we're going to need that to figure out our effect size if we're significant. And in this example, we do find a significant difference. People remembered more concrete words than they remembered abstract words. Now, to calculate the degrees of freedom, or not degrees of freedom, to calculate the actual effect size, it's still Cohen's d, but it's a different equation. What we're actually going to have to know is we're going to have to know the correlation, the mean difference, and the t, the degrees of freedom, and p. So if you look at the equation here, we're going to run through how to use this equation. But notice we're actually using some of the values that we need from that SPSS readout. So again, what we're looking at here is we're taking t, we're actually taking the calculated test statistic, 2.392, and we're multiplying it by the square root of 1 minus the r is the correlation, divided by the n in this case is 8, and then of course multiplied by 2, and then the square root. So let's walk through this equation. So the effect size here, here's the information we need. We need to know our n, we need to know our correlation, and we need to know our t-score. Our t-score is 2.392. Our r is 0.355, so 1 minus 0.355 is the first thing we're going to calculate. We're going to multiply that by 2, and then we're going to divide by 8. That's going to be a square root of 0.16125, which becomes 0.40155,946, and we're going to basically multiply those together. We have a Cohen's d of 0.9605. So remember, we already knew this was significant at 0.048, or rounded up to 0.05. So we need to figure out the effect size. We calculate the Cohen's d using this equation, and this is the Cohen's d we would only use within subjects or dependent t-tests, because we couldn't use it if we ran a regular t-test, because we wouldn't have an r score, because R isn't being generated by the previous test. Now again, we know a Cohen's d of 0.8 or higher is a large effect size, and that's what we find. There was a large difference in the number of words remembered in this particular experiment, and it was significant. So again, notice that n is based on equal n's. So if we were doing a match sample or any type of sample that actually requires that there's not the exact same people in each group, that's one of the reasons that it's highly important to try to make sure that you get equal numbers in your groups, even if you're doing matching, because the equations all assume equal n. And again, a Cohen's d of 0.2 or smaller is small, a d of 0.5 is moderate, and a d of 0.8 is large. Therefore, our d of 0.9605 is a large effect size. And just as again reminder, Cohen's d can easily go over 1.0, unlike R squared. So the summary of the results, we report this kind of like we'd report anything in SPSS when we're converting it over to APA. So first we define what did we run, a dependent samples t-test, and what were the variables, compared types of words, concrete versus abstract, on number of words remembered. Then we're going to make our statement. A type of word had a significant effect on learning. We're going to report that t, the degrees of freedom, the value of t. We're going to report our p-value. We're going to report Cohen's d, and then we're going to put it into English. And this has been cut off a little bit, but on average, students recalled more concrete words, mean of 13.25, standard deviation of 2.96, than abstract words, mean of 10.38, standard deviation of 3.02. And if we really wanted to punch this home, we might even provide a little bar chart that shows the difference between these two conditions. So the main points: dependent group t-test is appropriate when comparing two groups who consist of the same participants, or if the experimenter has made a specific effort to match those participants. When interpreting the results of a dependent t-test, we're always going to consider the statistical significance, how those groups differ, so how the groups were coded and what the means are. Once again, just like the previous test, we could get a positive or negative value simply depending on whether the larger group is first or the larger group is second. And once we find out we have a significant effect, we're going to calculate the effect size, the absolute difference between the means and the difference score, and that's Cohen's d. So just summarizing the difference between these two tests. The t-test for independent groups or a between samples groups is an inferential test for two groups when it's a between subject design, which means it's different people in each of our groups. It checks for systematic differences between the group's performance on the DV. Our assumptions are a categorical IV with 2 levels, an interval or ratio DV, bell-shaped normal distribution, homogeneity of variance, and that those observations were independent. Remember that bell-shaped distribution means that our DV across both groups is normally distributed, and homogeneity of variance means that the variance within group 1 is similar enough to the variance in group 2 that it's appropriate to look at those as a mean difference. And independent observations means that not only are they different people in each condition, we have made sure as much as we can methodologically that those two groups did not interact or affect each other's performance in the experiment. By contrast, the t-test for dependent groups is an inferential test for two groups with a within subject design or a dependent subject design. It checks for the systematic differences in individual performance within those groups, the DV. Again, we have one categorical IV with 2 levels, same. We have one interval or ratio DV, same. Once again, our overall distributions do need to be normally distributed, same. And we still need to look for homogeneity of variance. We don't have the same test that we did with the t-test for independent groups. However, we can just look at the normal distribution. If both outcomes are normally distributed, we have homogeneity of variance. If one is not and one is, we do not have homogeneity of variance. And again, in this case, we have the assumption that it is dependent observations, that our observations are being affected by the people, either because we have purposely gone in and matched them, or they're the same people. They're dependent on each other's scores because, well, of course my responses to one situation is going to be dependent on how I behaved in the previous one, because I'm the same person. So let's take a look at everything we've added to our toolkit so far. So we're going to start building on this decision tree. In other words, what statistic to use. And again, the first question we're going to ask of any study that we read or any study we're analyzing is how many variables. If the answer is there is only one variable, only one thing was measured, there's only a single variable in this study, we know that the only two things we could do in that situation is a t-test or z-test for independent samples. In other words, again, what we're looking for is single samples in this case. We're basically, the only thing we could potentially do is compare that variable to a pre-existing score. If the answer is there's two variables, we ask, is there a categorical independent variable, and if so, how many levels? If the answer is 2 levels, then we know we're asking a second question. Within those 2 levels, is it a between or within subject design? If it's a between subject design, we're looking at the t-test for independent measures. If it's not, if it's a within subject design, we're looking at the t-test for dependent measures. Now also remember there is one other option here, and that's going back to the 2 variable question. If we have 2 variables and we ask the question, is there a categorical IV? If the answer is no, we actually know that we then have 2 continuous, and that's going to be correlation or regression.